Shall we
Yes, sir.
start?
Yes, sir. You can.
Yes, please.
Okay. Yeah. Good evening, all the respected audience and my dear friends. On behalf of ICI Mangalore Center and QCrete Readymix Private Limited, we are most privileged to have our special guest for the day with his tons and tons of experiences on his favorite subject, and now it is our favorite subject also, and none other than CM Dodi sir. Welcome to the gathering, and
Thank you.
at the same time I would like to welcome one more specialist in concrete, Shelly Fernandez from MD of QCrete. Shelly sir, welcome. And we have Director Technical, Kaushika sir, welcome. And actually, to be precise, today's session will be very memorable for me, that my memories will roll back to the year 1998, when I had beautiful occasion to work with Dodi Sahab in great Gujarat Ambuja Cements. And so Dodi Sahab, it will be the memorable times.
Yes.
Those 2 to 3 years, I think we have learned so many things which we wouldn't have learnt otherwise, if at all, if I was not working in Ambuja and working under you as a technical officer. Anyway, thanks a lot, sir, for all the great lessons and teachings. And without wasting much of the time, today we are going to take up the 46th lecture series, online lecture series of ICI Mangaluru and QCrete Readymix. And once again, I welcome all the delegates and our special guest, Dodi Sahab, to this evening's function. Thank you so much, sir. Time is yours. I think Shelly sir will take over. Thank you so much.
Thank you.
Thank you, sir. Thank you, Baliga. Good evening, friends. Good evening, sir. My today's job is to introduce you CM Cyrus M. Dodi, or in short, CMD. If it is expanded, it can be Cyrus M. Dodi, or it can be concrete mixed design, actually. So no special need of giving an introduction. He is very well known in the industry, and also in this QCrete webinar series, this will be his 10th lecture, actually. So not much introduction might be required, but anyway, I'll go through his professional careers. He has over 50 years of experience. He has worked with Tata Powers for 20 years, from trainee to manager civil, and then the next 20 years in Ambuja Cements, from GM to consultant, and then 3 years he was a adjunct professor for IIT Mumbai, where he has passed his MTech from IIT Mumbai. And later on, he has received prestigious awards like ICF Postdoc Award for Outstanding Concrete Technologies 2006, Distinguished Service Award from IIT Mumbai 2004. He has organized around 670 Ambuja workshop series, covering 16,500 professionals for CMD, and 158 technical booklets, authored around 115 technical papers, delivered around 1,500 public lectures in India and abroad, actually. So with this brief introductions, I will not lose much time, actually, in handing over the mic to CM Dodi. I had the privilege of working with Dodi sir in Ambuja Cements for a period of 5 years, and my basic in concrete have been strengthened by many of his good, innovative, and practical applications. I'm really honored to have you, sir, amongst us. Thank you, sir.
Thank you. Should I start now?
Yes, sir.
Durability and sustainability are the keys to high performance concrete structures. Now, this is a very interesting subject and not only relevant to site engineers but also engineers who are working in the ready mix concrete industry. Many a times I wonder why this subject has come out of late, because of the use of fine and ultra fine materials in concrete. We not only improve the environment by getting rid of this very important concrete ingredient, and at the same time we give durability to the concrete structures which have now come into being as high performance concrete structures. Some years back, I was on a cruise from Barcelona back to Barcelona, and our ship was anchored at the Bay of Naples in Italy. Little did I know that the mountains which I could see from the window of the ship were the great mountains Vesuvius, and very, very famous for their pozzolanic material. In 79 AD, volcanic ash and pumicite, which is also called lightweight aggregate, containing almost 90% of volcanic glass, were used as pozzolans to build the Roman Empire. And the next stop after Naples was the Rome city, and we saw some structures there. Not that I have not gone there earlier, but it is a very, very interesting and useful memories for me. The importance of the Roman Empire, the surprise is that one of its structures, the Pantheon, has survived for more than 2000 years, and it is still existing as if it was built a few years or few days back. Such is the magic of the pozzolanic material when used in concrete. The Romans earlier tried to use this volcanic ash as a part of sand, and later on realized that it also has very good cementing properties, and therefore the fly ash became very popular, or the volcanic ash became popular, and now because of the super thermal power stations all over the country, the fly ash is one of the ingredients, and it is not going to waste. Ultrafine and fine material are being used, as I told you, over 2000 years, and this is one of the structures called the Colosseum. Colosseum was like a stadium built in Rome and having a capacity of nearly the Wankhede Stadium in Mumbai. The stadium or the Colosseum was useful to the Roman emperor, who would be punishing some of the citizens for not doing their job correctly, etc. And the punishment was very simple, that early morning the people would assemble, and the person to be punished had to fight with bare hands a hungry lion. And if he was strong enough to kill that lion, then he is forgiven of all the misdeeds he did. If not, then he becomes a good breakfast for the lion. Now let's see why concrete shows poor durability. There are many, many reasons. Only a few important ones I am going to show you. The main reasons: poor specification and understanding of materials and concrete. So one has to brush up, learn, experience the feel of concrete in the field, and produce some durable structures. Poor detailing in the drawing. It is very important that very often details are not shown clearly in the working drawing which are received on the site. The drawing should be thoroughly studied, including the notes which are written on the drawing. Poor quality control at site. Oh, I can talk volumes on that. And this is an extremely important feature which is most neglected, unfortunately, by the civil engineers and also by some of the civilians who have ventured into the concrete industry, thinking that it is not just the civil engineers who have to work with this material, but even citizens or normal civilians can also do. And I think they are mistaken. Poor availability of good quality materials. When my career started in the civil industries or construction industry, the sand availability was a big problem in Mumbai. The quality was very, very poor, and we had to literally struggle to get good sand or to convert the bad sand to good sand. Poor availability of easy testing methods at site. Most of the tests on durability are difficult to be executed at the site, and therefore we have to wait for years, 25, 30, maybe 100 years, if we survive concrete. Then without the testing methods, we have only prescriptive methods that, yes, like for example, if you put low water binder ratio or low water cement ratio in concrete, then you are bound to get durable concrete, but it has to be monitored properly at site. Poor quality of construction equipment, but now the new civil engineering generation has come into being with the ready mix concrete plants. So this is a problem which is more or less solved, but still, even having good plant, good quality materials, you must have good supervision also. And last but not the least, ignorance, negligence, and carelessness has to be removed from the minds of the constructor. And it is very, very important that if you are ignorant of the concrete material properties and its existence, will become difficult to understand. Negligence, carelessness are the other two. But the last one, the greed, I don't have to explain to you. There's plenty everywhere in the world, and it is very important that if you are a civil engineer, you should not have any greed. But it is at the same time very difficult to get such human beings. Now I'll quickly go through why concrete loses its durability. I'll click this slides fast, otherwise if I click one by one, it will take a lot of time. Now you see the various photographs there, and generally concrete has lost its durability because in RCC we use steel which is very vulnerable to corrosion. And if proper care is not taken, there will be corrosion, and within a few years' time, the durability of the RCC or the concrete structure is lost. The first important thing is corrosion takes place when water enters and reaches the reinforcement inside the concrete structure. The chlorides cause corrosion, and of course, for any reaction to take place, there has to be oxygen. One good thing is there, if you don't have oxygen, then corrosion may not take place and the durability will be okay. Salt water penetration is most harmful because salt accelerates corrosion and causes serious problem on concrete. The steel gets converted to iron oxide, or what we call as rust. It expands, cracks the concrete, and further ingress of salt water and oxygen will completely deteriorate the concrete. Concrete starts spalling, and that is the clear sign that concrete has to be repaired. Leaching is another problem. If the water saturation takes place and the calcium hydroxide, which is present from the reaction with cement and water, is in excess, then the excess lime leaches out of concrete and leaves a passage behind for water to enter wherever the leaching has taken place. Alkali aggregate reaction, it's very rare in our country, very, very important, but in UK, there is an area which gives a lot of alkali aggregate reaction. So we are lucky. This happens because the alkali in the aggregates come in touch with cement and produce a material called attringite, or it is an expansive material. It expands and cracks the concrete. But here too, the alkali aggregate reaction only takes place where there is water or high level of moisture in the atmosphere. Sulfate attack also can take place. Generally, the seawater contains chlorides and sulfates. Many a time people forget that chlorides are more harmful than the sulfates in the groundwater and subsoil. So one has to make sure that the sulfate attack is minimized, and the best way now known to engineers is to use the zolonic material, slag, or maybe fly ash from a thermal power station. But essentially, these materials have to be good and produced in the right way so that they can protect the concrete and avoid the expansion due to sulfate attack. Again, attronite is produced, which causes expansion and cracks in concrete. If you don't make concrete properly, you will get cracks right from day one to the end of its life. A little background on the materials, and I always explain the materials and give them analogy of a human being. Now, there are plenty of materials which are being used in concrete. So I am going to show you a rural family, not an urban family, because we can't have many children and produce bad quality concrete. The first is the cement. Cement is generally, I would compare it with a head of the family. And thank God, in the early days of my career, we used to get only 33 grade cement, but now we get 53 and even better quality cements are now available. Water, I compare with the eldest son in the family, the Ladla Beta. Generally, we have observed that the eldest son is pampered the most, not the eldest daughter. And therefore, the durability is lost if you have too much water in your concrete. And one has to give the priority that water to cement ratio is extremely important. Lower the water cement ratio, better will be the durability. Then we produce fine aggregates and coarse aggregates to be used in concrete. In India, unfortunately, we don't have standard aggregates. There are standards and there are specifications, but they are not available in the market easily unless the contractor takes upon himself to produce standard aggregate. So we produce the aggregate in general terms, just like the children in a family, without much quality control, and therefore, again, durability is at risk. There are admixtures, high performance water reducing admixtures and other admixtures which are used, and one has to have very good compatibility with cement and other materials which you use in concrete. In fact, each material should complement the other, and if they are non-compatible, then you are in trouble. You may not get the results what you are aspiring for. Then comes the most important admixture, the mineral admixture, what we call as slab, fly ash, ultra fine materials. All of them are classified, and I compare them with the mother-in-law in the family. Generally, it is seen that there is no value for mother-in-law. She's become too old to do any work. But no, if she is encouraged to do the correct task in the family, she can make wonders. So this material has performed, though sometimes the mother-in-law takes a longer time to adjust with the daughter-in-law. Yes, even the mineral admixtures take a longer time to gain the strength, etc. But all the same, they perform properly if used properly and in correct proportion. Again, the choice of the mineral admixtures is also very important. Not all fly ash available or slag available can be used in concrete. They can produce adverse effect. So therefore, the correct specification has to be, the material should have the correct specification so that it can be used as a pozzolanic material, and the full advantage goes to the structure. Then of course we have other materials like fibers and the ultra fine material. Ultrafine material do exactly perform like the young children in the family. They have to be carefully monitored. They have to be carefully proportioned and used in concrete, and they can really work wonders. And generally, they should not be used in isolation. They should be ultrafines should be used with the fine material so that the mortar or the binding paste which we make for concrete is very solid in the sense it can block all the chemicals from coming inside and harm the reinforcement in the concrete, etc. And at the same time, give additional strength, which cement itself will not provide. So, consistency is the key of high performance family, and consistency is the key for the concrete also. What is necessary for durability? Material used in concrete should be compatible with each other, like the family members in a family. Non-standard or at times substandard materials should not be used, like the aggregates or even the fly ash and slag. Materials used should be free from deleterious materials. So the deleterious materials either should be removed or materials containing them should not be used. In ordinary concrete mix design, we give only importance to packing of the coarse material. That means the bigger size aggregate goes into the finer size material, etc. And you get a nice compact skeleton of aggregates. But we should, in high performance concrete, we should also give importance to the particle packing of materials in the binders. The cement is the coarsest binder, and the microsilica will be the finest one, or what we call as silica fume. But there are others now available in the market, the ultrafine slag and the ultrafine fly ash. They are excellent packing materials. We must give importance to the water binder ratio. Earlier, we used to call it as a water cement ratio, but because now we are putting binders like slag, fly ash, ultrafine materials, etc., we call water binder ratio is important. Lower the water binder ratio, better will be the concrete quality, as well as it will have good durability. One should not be averse to using materials like slag, fly ash, etc. When I was training the engineers in Ambuja Cement, I used to always say that you will never be able to make high performance concrete if you don't use this materials like slag, fly ash, etc. Of course, of the correct specification. Otherwise, you will lose this waste material and not make a concrete which is durable and also sustainable, because these materials should not be wasted, in my opinion. Gone are the days of excessive use of OPC. These materials also help in reducing the cement content and not the cementitious content, and the water also. But last but not the least, please understand that curing is very, very important. People never understand that. Even today, on big sites, etc., curing is the most neglected exercise of making concrete. Important requirements, just to compare ordinary concrete and high performance concrete. I am showing you this slide. Ordinary concrete is like ordinary tea. Everyone can make it and drink it, but its performance is questionable. There are some special people who have high tea in water in Tahiti Lake, or some ducks can sit and swim in the cup of tea, and maybe we can have the non-vegetarian tea, not recommended. Let us see how high performance concrete looks like. If you see high performance concrete, it consists of air and free water, about 2%. The hydrated paste, which will be about 35% by volume. The aggregates, if you consider fine and coarse aggregate, totally 100% aggregates means fine, generally fine aggregates will be 40% and coarse aggregates will be 60%. Variable depending on degree of reaction between cement and water. So binder ratio may change a little bit. And on exposure conditions, if we are having aggressive exposure conditions like the fluctuating wave at the high tide and low tide, which gets alternate spray of seawater and alternate sunshine, can be very vulnerable to cause corrosion on the steel. Microfine and fine materials like slag in combination. Never use only microfine material or fine material in isolation. This is my experience and suggestion. It will really give good performance. I remember one very interesting incident which took place in Ambuja Cement. I visited one of the production plant, and our technical officers were discussing that with the OPC which they were getting there, they were not able to produce M100 grade concrete. So I just simply smiled and told them, what have you added with your OPC? So they immediately said, oh, we have used the ultra fine slag which is available and produced by our company in Goa, and we are not getting M100. So I told them, have you used this slag with the ultrafine slag with the PPC cement? PPC cement was containing fly ash and of course the clinker. So they tried that, and believe me, they could succeed in getting M100 concrete. Generally, the belief is that oh, fly ash will always give lesser strength, etc. No, nowadays for high performance concrete, the packing of the material in concrete is extremely important. So even if the aggregates are properly proportioned, they should be, and we have to pack the mortar, the paste, the binder paste. It has to have fine and ultra fine material both. In addition to cement, you should have slag or fly ash and the microfine admixtures, mineral admixtures like the ultrafine slag or ultrafine fly ash, etc., or microsilica. These are excellent materials. Superplasticizer has to be always added by weight, not by volume. So it is very important to measure the superplasticizer, which often comes in form of a liquid, by the solid content. One has to first inquire with the manufacturer of the plasticizer how much is the solid content in the plasticizer, and that percentage you have to add, discarding the liquid which is added for convenience of adding the plasticizer to the concrete mix. High performance concrete. Believe me, this material, high performance concrete, only came into being somewhere around 1970. And everyone was trying to change the philosophy of high performance concrete. Generally, when I started my career, I used to be very happy once I get the required strength. But I used to never bother about the durability. This was a wrong concept in my mind. And when high performance concrete came into being, it was very clearly justified that strength through durability is a must, and not durability through strength. Means you should target durability and not think that because you have got good strength, you will have durability in your concrete. This is a very important lesson I learned once the high performance concrete came into being. Even American Concrete Institute took a long time to define high performance concrete. And it came in 1998. Remember, I told you 1970, the concrete, high performance concrete people were dabbling with. So what is high performance concrete definition? Concrete meeting special combination of performance and uniformity requirement that cannot always be achieved routinely using conventional constituents and normal mixing, placing, and curing practices. Mind you, what is important now, we do several steps while making concrete. So, of course, proportioning of the aggregates and all material is important. Normal mixers may not work. You have to have high performance mixers like the ones we get in the batching mixing plant of the ready mix concrete. Placing of the concrete has to be done correctly, because if you segregate the mix, you can't get dense concrete. And last but not the least, curing cannot be neglected right from the beginning. I will come to that in the last part of my lecture. What are the special combinations of performance required by HPC? Well, you can target high early strength or late strength, high elastic modulus and low creep, high workability. See, these are all the special requirements of high performance concrete. You may select one or two or maybe all. Sulfate and chloride resistance, frost resistance if it is done in very cold climatic conditions, chemical resistance, and abrasion resistance. Even you can make spillways of the dams where there is very high level of abrasion from high performance concrete. Just to give you a very simple and practical thing, you see material combination and the role of rheology in concrete. Conventionally, we were using only cement. So the gaps between the cement particles used to be filled with water. And later on, the water would disappear, causing shrinkage and cracks. Now, in high performance concrete, we are very sensibly using the fine and ultra fine materials like fly ash, slag, ultra fine fly ash, ultra fine slag, silica fume, etc., and packing the cementitious material. So when you pack between the cement particles, the cementitious material, after the complete hydration process is completed, there is hardly any water within the cement particles, and the whole thing has been transformed into a solid material. So if you have such a gel made and it packs the aggregates properly, you get high performance concrete. Particle packing and density concept. Now, particle packing of a system is a function of the following. You'll get more details from one of the booklets, which is in the Ambuja lectures, in Ambuja's literature series. And I will not take you into much of a detail, but I will simply explain to you in a short form. Particle size distribution, just like we have got sieve analysis of aggregates and we see the particle size distribution of the aggregates, we also must see the particle size distribution of the fine and ultra fine material. Particle shade, fly ash and ultra fine fly ash are superior to, I would not say superior, but they are better and more efficient because their particle shape is spherical and they consume less water. Particle surface, if it is crushed aggregate or crushed ultrafine material, then the particle surface will be rough, whereas if it is spherical, it will be smooth. Ratio between system size and maximum grain size, just like we select the maximum aggregate size, you want 10 mm downgraded concrete or 20 mm downgraded material used in concrete or even 40 mm. The ratio between the system size and maximum grain size is important. Presence of liquids, where they help in workability and compaction of the concrete. Just to show you or give you an idea of the various types as seen through a microscope. Now we had the facility to use the laboratories in IIT Bombay and IIT Chennai, Mumbai and Chennai. And you can see how OPC looks under magnification. The fly ash, which is generally used in the RMC industry, some coarser grains, some finer grains are there. The ultrafine slag also, which is used in RMC industry. Now, one thing you must remember, ultrafine slag is made by grinding the normal slag. And when you grind any substance to ultra fineness, the shape gradually turns into spherical, but not actually spherical. Fly ash used in high performance concrete, you can use properly different sizes of fly ash together in high performance concrete, quite unlike the fly ash generally used in RMC industry. Then of course ultrafine slag, which is also very good packing material Now slag has a little advantage over fly ash because it also contains calcium hydroxide. So it will chemically also influence the strength of concrete, whereas fly ash will not chemically influence the hydration process in concrete till it is soaked into calcium hydroxide and then it starts reacting at a later stage. But it has the advantage because of its spherical nature. Now everything we do in the mix design has to be linked with the specific gravity of the material, especially when you are designing the proportion of cement and the other ultrafine material. In IIT Bombay, we had the facility to use the picrometer. अभी काम था मीटिंग ultrafine material using picrometer give much accurate specific gravity than the La Chatelier's flask. So, but that's a matter of how accurate you want to be. We have found that if it is picrometer is not available, then you can do with ultrafine materials also using Chatellier's flask. This one, picrometer gives you more accuracy. The Punke test or the Punka test was first came into being many years ago when people added fly ash to cement and called it a binder. So water which is added to the dry binder, blended materials or dry fillers in combination, fills the voids in between the particles, as I showed you in that sketch, and acts as a lubricant to make the material compact efficiently. Water which is in excess, after completely filling the voids, appears at the surface of the mix and indicates that now the material is saturated with water, and that is the saturation limit. Packing density is calculated by this formula where VW is the volume of water which is required to be added till the gel gets fully saturated, and WS is the volume of the solids. That's how we do this simple test called the Punka test for packing density, very important. Weigh all the dry materials, all the like cement, etc., fly ash, whatever you are going to make the blend of. Then mix it by a spoon, dry material first, compact it on a vibrating table type of arrangement. This is cement, this is slag, this is the ultrafine slag, and this is the fly ash, all mixed together. Add water little by little, again mix it till you see shining particles coming out, means now the water is trying to come out of the fine material and the mix is saturated. So that you must now stop adding further water in this mix. So this is a very simple yet crude yet simple, but it gives you an idea how much should be the proportion of water in the binder, combination of binder. Now, how does the improvement take place in concrete properties? Let us see when concrete is in plastic form. Because you are adding fine materials and because you are adding certain rounded materials, and your viscosity and cohesiveness of the mix improves, which is very, very important. It prevents segregation when you are placing the concrete because the concrete is now viscous. It helps in pumping of the concrete. The pump doesn't get choked so easily. The second is workability. You need a chemical admixture, yes, but there is certain workability introduced or the flowability introduced because of the, if you are especially using fine material like fly ash. So plastic concrete gets improved workability. Fine materials like slag and fly ash and their ultra fine materials, the workability gets retained for a longer time because the fine and ultra fine material take a longer time to gain strength. So one, it is good when you are using these materials in pump concrete because, or even while transporting concrete, you take a longer time, so workability retention is improved and thereby compaction can be done even for a little later time. Flowability, there is a difference between workability and flowability. Workability means you can work with that concrete material. Flowability means you can make sure that the concrete flows like sometimes like water. You must have seen when we sort of produce flowing concrete, which does not need any compaction. Concrete just flows like water, but it does not allow the materials to segregate. And once you get all these things, your pumpability increases. Sometimes we measure pumpability by lump cone, sometimes by the spread. This is one example of Kinky Financial Sector where they produce C120 high performance concrete. The spread initial was 610. The slump was 270 millimeters. And after 4 hours, the retention was 590 millimeters of the spread and slump dropped to about 40 millimeters. Improvement in pumpability due to fine and ultra fine material. Forms a good lubricating layer on the internal pipe surface. Imagine you are squeezing the concrete while you are pumping. The pressure is applied from behind by the pump and the resistance is offered by the roughness of the pipe. So the concrete gets squeezed. And when concrete gets squeezed, anything you squeeze, what comes out? The paste. The paste comes out on the surface of the pipe, internal surface of the pipe, and lubricates the pipe. Therefore, it is very important that fine and ultra fine material is used. It improves the lubrication layer, and therefore pump does the pumping without any difficulty. It also reduces wear and tear of pump line. Remember, when we did unit number 5 in Trombay Thermal Power Station, the aggregate used was gravel. Also, to some extent, admixtures were used. In the other project, unit number 6, we could not get the gravel aggregate, so we had to use crushed aggregate. And immediately the wear and tear on the concrete pump lines increased because they were rough, and probably we were not using at that time the fine and ultra fine material. Otherwise, it would have protected the pipe to some extent by not allowing the rough edges of the aggregate to get in touch with the pipe and cause abrasion within the pipe. So it is a costly affair. We have to change the pipes more frequently than what we did in unit number 5. Another thing, reduces the chances of stiffening in the pipeline. If there is a problem with the pump or the batching plant and the supply is not there, then you can still wait for some time and give a gentle stroke every 10 or 15 minutes so that the initial viscosity is not there. And when you resume the pumping, it will cause a smooth flow. Prevent mix aggregation and chokes. Now, what happens if you have noticed any choking of the pipeline while you are pumping? There will be two things you will notice. One is that the aggregate has formed a choke. The material which is required, the cementitious binding material which is required, is not present. This can happen when there is a segregation or there is a high level of fluidity in the mix. The finer material, due to the pressure of the pump, has vanished or has got removed, and only the aggregate have come in as a choke. The other thing could be that the entire concrete is intact, and to see the aggregate, it has formed, or the whole concrete itself has choked the pipe. This can happen because of low workability and also greater stiffness in the concrete mix than necessary, or flowability is not there in the mix. So chokes can happen, but can be avoided by correctly using the concrete materials and other ingredients in the mix. Concrete rheology is studied in many places, and this is called a rheometer. Rheology is a scientific description of the flow. We are now not interested in the workability, slump and all. We are interested in the flowability of the mix in the pipe. The rheology of concrete is measured with a concrete rheometer, which determines the resistance of concrete to shear flow at various rates. Now, initially, the concrete has to break the friction between the pipe and the concrete which is being pushed through the pipe. and therefore the initial yield stress is important. And later on, as the concrete has broken the initial yield stress, it will again flow, and the concrete rheology measurements are typically explained in the Bingham model, which is friction of yield stress, function of yield stress, the minimum stress to initiate the and or maintain the flow related to slump or spread, the plastic viscosity is the resistance to flow. Once the yield stress is exceeded, then the concrete starts flowing, and related to the stickiness of the mix and the surface. Shear stress, yield stress, and plastic viscosity are important to measure the flow curve. Concrete rheology provides many insights in concrete vocabulary. Lump and slump flow are the functions of concrete rheology. This is very, very important that you not do the measure, etc. I will show you one example. These are reverse pumping. From the bottom, the concrete is pumped into the fountain. And this is the flowing concrete. Sorry, I have to escape. This is jacking of concrete. See how the concrete is rising. Now it has reached the top and it will overflow. Ge in Chinese language means stop, stop, stop. So you also learn Chinese language because this video has been taken in China where they were constructing a tennis court columns and doing this reverse pumping of a C60 grade concrete. Yeah, absolutely. Ah, thank you. Now, C120 high performance concrete for super height pumping. This was being done when this building was being constructed in China, the financial center. Pumping performance of concrete work under high pressure has to be finalized only after simulating the height of long distance pumping mock-up trial. Low viscosity and plasticity of concrete in order to achieve good pumping at height need to be carefully evaluated prior to actual field pumping. This is very, very important, and see how they do the simulation. Instead of putting a pipe vertically up, they have lots of bends and horizontal length of pipe, which is equivalent to the height of the building. There is a conversion table available. Roughly one vertical, 1 meter long vertical pipe equals to about 2 to 3 meter long horizontal pipe, because lesser friction. Vertical means more power is required. So once you have done the mix design, you have to try it out with this type of an arrangement and see whether the concrete will flow to the required height in actual pumping. Improvements in hardened concrete when you use all these materials, fine and ultra fine, the strength improves. It is observed that even 28 days strength increases. After 28 days also the strength increases, because you have got the pozzolanic material in your mix. So that is an advantage. Strengthening of the interface between the aggregates and the binder. You must have observed that when you crush a cube, the failure of the cube takes place, one, as a result of the aggregate itself getting crushed, or as a result of the paste getting stressed and cracked. Most of the failures of the cubes are at the interface. When you do concrete testing of M60 grade and more, then it is very important that you have to strengthen the interface between the aggregate and the binder paste. Otherwise, you won't get such high strength. And the interface between the aggregate and the binder paste is strengthened due to use of fine and ultra fine material in the paste. Shrinkage reduces like anything, because now you have removed the water and replace it with a dense, what I can say is a dense gel, replacing the water with a dense gel, which will harden and reduce the chances of shrinkage due to loss of water from the mix. Naturally, durability improves because your mix is now hard and strong and also gaining strength. I'll give you one example which we did in with different mixes, and the first mix was a reference mix. Only cement was used. The second mix was using ultrafine material, ultrafine slag 7.5%. The third mix, ultrafine slag 15%, and then ultrafine slag only fly ash. And the last one is ultrafine slag with a 10% ultrafine slag with 25% fly ash. Now all of them had cement content varying from 500 to 325. This was the least, because we have used both fine and ultrafine material, and the strength was the best. This is getting hidden. But it was about 88 or so, 85 or 88, I think. If I click this, then there will be a problem. Anyway, so the strength was best. With only 325 we could get so interface has to be strengthened, and if the aggregates are also failing, then aggregates have to become stronger or get a better source to give you higher strength aggregates. But generally, the interface, if it is strengthened, you can exceed 60 to 80 to 100 megapascal strength. The strength limiting factor may be aggregate or binder paste or interface between. So here, if you are aspiring to do 100 grade concrete, then of course the interface has to be strengthened. Chloride ingress in concrete. This is a very simple way to show how it affects. The first is surface absorption of chloride. If chloride ingress is there in concrete, some of the chlorides will get absorbed due to the anodic action of the hydrates, and it will take a little longer to reach the steel when there is low water to binder ratio. It's important. The next is the tortuosity and the permeation of chlorides. Now, tortuosity can be higher when you are using mineral admixtures in binary blending, means both coarse and fine mineral admixtures together. It is like the pores will be having tortuosity, and with the proper packing or with the proper mixing of the binders, it will have more tortuosity, so the water will take, or the chlorides will take a longer time to reach the sea. And the last is ultrafine mineral admixtures, ternary blending, particle packing in the binders also is taken care of. Then it will have a very complex way of chlorides going to the steel, and the route will be much longer, and by the time the concrete will harden and therefore prevent any sort of attack of chlorides on the steel. Chemical binding, if we are using aluminate, slag, etc., then the chloride will hang on to the various particles of slag and are prevented from reaching the steel. And all this together shows that low water to binder ratio is very important. Use of mineral admixtures in binary blending and ultrafine use of ultrafine mineral admixtures, ternary blending, and particle packing play an important part in preventing chlorides from reaching the steel, and therefore durability loss is arrested. The only disadvantage of high performance concrete is fire. Now this is a photograph taken of the Euro channel when it was constructed. The liners are there made out of high performance concrete. And you must have heard of a fire taking place within very few months of the tunnel being commissioned. And the temperatures went up to 400 degrees centigrade. Inside the tunnel, the heat was much more. It was not an open fire where heat could get dissipated, etc. And the rapid heating condition, cracks, appeared on the surface and will not easily lead to when the high strength concrete is crushed, the bursting takes place because steam generated by the fire is not allowed to easily come out of the concrete, which is being crushed. So now the method has been developed that you put some fibers, reinforcement fiber, in the high performance concrete, and should in case there is a fire, the fibers will melt and do not allow the concrete to burst. The steam will let go very comfortably and no bursting can take place, and bursting can cause serious injuries to workers, etc., who are present very close to the concrete surface. High performance concrete are now in use extensively due to advantage of high strengths. What are the advantages? Contractors will certainly like it. Reduction of concrete content by 40%. This will be the client's dream. Reduction of steel component by 39%, because now the concrete can take a lot of tension. Reduction of construction cost by 20 to 35%. Everyone will like it. If we are replacing 40 megapascal by 80 megapascal concrete, then reduction in volume of the structural member will be higher. Static load is reduced by 30% in the design. If 60 megapascal is replaced by 150 megapascal, reduction in column cross section and increase in beam span, overall reduction in cross sectional area and increase in building usable area. Now what happens is, when the World One was being constructed in Mumbai, they were also in lookout for M100 grade concrete. And the experience was very less at that time in India. And the client had to visit places here and there to find out the solution. And in the meeting, they told us that if they make concrete of M90 grade, then the spacing between the columns will be almost zero. So you won't be able to enter the building at the ground floor level. So it will be useless. So they suggested that when the consultant suggested that we must have M100 grade concrete, especially at the lower levels, so that the spacing is enough between the columns for human beings and other maybe furniture, etc., to enter the building. So they were struggling to get M100 grade with the materials available in Mumbai. Ultimately, they had to fix design with a very scientific way, complying with all the requirements of high performance concrete, and they landed up with say around 98 megapascal strength, and at the same time could get enough access at the ground floor level. The building is now completed. People can go and see that. Last thing, curing. High performance concrete must be cured quite differently from usual concrete. The use of curing compound has no value in inhibiting autogeneous shrinkage. Now, generally, the curing compounds are used so that they inhibit autogenous shrinkage. But in this case, when the concrete is very high strength, it is strongly recommended to do wet curing and not use curing compound. The wet curing can be done for the first 2 to 3 days of placement and finishing, and later on you can continue doing curing with curing compound. Contractors must be specifically paid to cure concrete. It is a profitable investment because otherwise it will not be possible to have high performance concrete if wet curing is not resorted to in the first 2 to 3 days. Conclusions. For proper particle packing, ultrafine material have to be used in conjunction with fine material. They give better durability. Shape and size and particle size distribution of the fine and ultrafine material play an important role in workability, cohesiveness, pumpability, flowability, and strength. In high performance, fine and ultrafine material play a very important role in strengthening of the interface between the binder paste and the aggregate. If particle size distribution is identical, lime and pozzolanic reactions play a key role in strength. So this point is to be borne in mind. Free water and entrapped air get reduced due to binder paste when fine and ultrafine material are used. This reduces shrinkage and cracking. Mixing has to be done properly when fine and ultrafine materials are used. Colloidal mixers may be necessary or mixing time increase when ultrafine materials are used. Chloride saturation test. Now, generally, the underground system, railway system or underground trains, etc., they are recommending that RCPT test has to be done. Chloride saturation test is the only authentic test for chloride penetration and not RCPT. ISO only recognizes chloride saturation test. So please don't waste your money and time doing RCPT. You must do chloride saturation test. Maybe it will take a little longer, but it will be the correct test. Durability and strength are greatly enhanced if fine and ultrafine materials are used in concrete proportion, correct proportion in concrete. Now I end my lecture with a joke. Quality assurance program for a newly married engineer who wanted marriage to be durable and sustainable. So he was very happy with a big broad smile at the time of his marriage. After 2 years, he was in trouble. The quality engineer married an average girl. After 2 years of tough life with her, finally, engineer got angry and sent a note to the father-in-law stating that these days they will send faster notes, email bhi bhej sakta hai. Your product not meeting my requirement. The clever father-in-law replied, warranty expired, manufacturer not respond, because he had said only 1 year guarantee for his civil works, and therefore he is not responsible. Okay, friends, so I end my lecture. If there are any questions, comments, feedback, then you can address it to the technical department of QCreteIndia.com or Mr. Kaushik at QCreteIndia.com. Questions, please. Anjali?
Thank you,
Uh,
Dodi sir. I think we listened to a fantastic lecture, and as usual, you have delivered this lecture in a very unimitable and one and only way, Mr. Dodi's way. And we from QCrete India Private Limited, we are extremely, immensely, infinitely thankful to you, sir. Your knowledge is I don't think we have given enough time. Probably the lecture will go on. You are an ocean of concrete technology, and the experience is like a big mountain, and we are really thankful to you. And we are also thankful to all the audience who have been listening to the lecture from this young lecturer, 75 years old, going strong. Yeah, and we are also
I'm 74.
we are also infinitely thankful to you for being a role model for all the concrete engineers, concrete QAQC engineers, even at this age, showing a huge path for us with your interest and passion in concrete. Once again, we are all thankful from QCrete. We are blessed to have you today with us, sir. Thank you very much.
Thank you, QCrete, for giving me this opportunity to address so many engineers at one time. Thank you. Any questions or comments or whatever?
We will send it to you. We will send it to you, sir. Any questions?
Okay. So you send me about at least 10 questions which you feel are most relevant to this lecture.
Yes, sir.
And I will reply. But you will have to send me the email IDs of the persons who have asked the question.
Yes,
and
sir.
the question itself.
Yes,
Okay.
sir. We'll do. Yes, sir.
Thank you.
Thanks a lot. Thanks a lot, sir. Thanks a lot. Thanks to all the audience. We will come up with another program soon. And we once again thank today's speaker and the Bangalore Concrete Center, Mr. Anil Baliga and all his colleagues for providing this opportunity. Thanks a lot.
Thank you, Anil and Shelly. Okay.
Thank you so much, sir.
Thank you, Anjali madam. Thank you.
Thank you.
Thank you so much, sir.
Thank you, Anjali. Lovely work.
Thank you, sir.
Well done. Yeah. Send me the questions soon. Thank you.
Yeah, okay, sir. I'll send you.
Okay, I close my presentation now.
Yes, sir. Yes, sir.